Okay, so this is a video to help you with 4.8, the worksheet or the practice. So with this, we're going to talk about the base angles theorem and the base angles theorem converse, or the converse of the base angles theorem. We're also going to talk about the corollaries to the base angles theorem and the converse of the base angles theorem. So to start, in the diagram, I got this beautiful diagram here. It's going to tell me if these two sides are congruent, what two angles must be congruent, and then tell me what theorem you used. So AE is congruent to CE. So if AE is congruent to CE, my two legs are congruent. So if my two legs are congruent, I'm going to tell you what base angles are congruent. So that's the base angles theorem. So this would be the base angles theorem. The angles opposite of those would be this little guy and this little guy. Okay. With those being congruent, it would be angle EAC. So this would be angle EAC is congruent to angle ECA. Okay. The next one I'm going to do with you is we're going to look at here to number 3. I'm just reading it so I figure out what kind of color I want to use. I'm going to use red with this. Okay. So if angle BDF is congruent, so that's this little guy, congruent to DBF, which is this little guy, to BFD, to this little guy, then what sides are congruent? So by the corollary of the base angles converse, or the converse of the base angles theorem, given congruent angles, we know sides are congruent. So this side, and this whole side would be congruent. So that means I would be looking at equilateral triangles. So this is the corollary to the base angles converse, because I'm stating that sides are congruent. So it would be segment BD is congruent to segment BF, which is congruent to segment FD. So that's what's asking you on 1 through 4. 5 through 7 is asking you to tell me what the measurement is. So if you know something is equal in angles, or the sides are equal, if the angles are congruent, then the sides are congruent, so the measurement is equal. If the sides are congruent, then the angles are congruent, base angles mainly, normally, because two of these are isosceles. This one is equal angular. So with that, this would be, since the sides are congruent, angles are congruent, so the measurements must be equal. And the same thing with on number 7. Number 8, you're doing algebra, which is what we did in our notes. So if you look back at your notes, I will scan them up and everything else, and you'll have those up there. So we're going to sit here and we're going to look at some other ones. These ones down here are going to be similar to what are in your notes or are from your notes. On the back side, find the perimeter of the triangle. So after you find the measurements, perimeter of the triangle is add up all the sides. So you're going to use the converse, the base angles theorem, the corollaries of the base angles theorem, and the converse of the base angles theorem to find the measurements of x. And then what you're going to do is you're going to plug that answer in and you're going to add up all the sides. Number 23, you're going to look at that and answer the question. 24, there's a proof, and you're going to work through it and you're going to go through and figure it out. If it says corresponding parts of congruent triangles are congruent, this is CPCTC. So you're going to find a little part that is congruent to each other, working through to figure out ADC is isosceles. So if you're working on that, you're going to have to figure out some measurements or some angles of what's going on and figure out how you can get that measurement to equal out. So probably based on what angles are congruent, based on angle side angle. And then what angles do you need to prove that, or sides, you could do sides, prove that's isosceles, because that would be definition of isosceles, or the base angles theorem, or whichever way you want to go with it. So it depends on what is said. Remember, the definition of isosceles is that there are at least two legs or two sides congruent. So since that's the definition of isosceles, I guarantee that's what you need to do here. Good luck.